So we're going to take problem questions, questions on the kinematic stuff, questions on graphing, questions on whatever we need to take questions on. We will be little question beasts today. So, what do we got here? Which one do you want to start with? Okay, which worksheet? Okay. So problem set from chapter 2. Okay. And let me get my book. Oh, no, those are Giancoli, sorry. I need this book then. It's Giancoli, isn't it? Yeah. Guided practice? Okay, so it's the guided practice.
I think guided practice would actually guide you.
Yeah, one would think. That's not exactly how it works. Okay, I'm looking for... There it is. Okay, so problem number 1 says a car accelerates from 2 meters per second to 10 meters per second in 4 seconds. If the rate of acceleration is uniform, what does that mean? It doesn't change. If the rate of acceleration is uniform, determine the rate of acceleration and the distance traveled during the 4 seconds of motion. So anytime I start a problem with this, this is the Giancoli guided practice number 1. So we don't know the original position, we don't know the final position, the initial velocity, the final velocity. I always start my problems by listing everything I know. So I don't know acceleration, and they asked me to find it. The time was 4 seconds? 4 seconds. Okay, and then they tell me too, it accelerates from 2 meters a second to 10 meters per second. So that would be my starting velocity. 2 meters per second. My ending velocity. And one of the things you generally get to pick is you get to pick the starting position. So most of the time we pick the starting position to be 0 because that makes it a lot easier to deal with. And then we don't know final position, and that's the other thing they're going to ask me. So for part A, I'm going to use the shortest equation, V final equals V original plus AT, because the only thing in that equation that I do not know is the acceleration. The only thing I don't know is the acceleration. So then I'll fill in what I know. We end at 10 meters per second. We start at 2 meters per second. We have an acceleration. And we have a time of 4 seconds. So I subtract on both sides. And that gives me 8 meters per second equals A times 4 seconds for 1, which I then multiply by the reciprocal. So my acceleration becomes 8 meters per second squared. Bless you. No, 8 divided, because 8 divided by 4 is not 8. 8 divided by 4 is 2. Yeah, it's that kind of day. Yeah?
I just did change in velocity over time.
Yep, that's exactly what that equation is.
Oh, okay.
Because I did V final minus V initial, which would be change in velocity. Then I had to divide by time.
Okay.
Yep, it is that equation.
Okay.
I'm waiting to see if there's questions. So,
I was really just looking for B of that one.
okay. Kind of need A to do B though.
Yeah.
Nathan, how did those free response go in the multiple choice?
Great. One's Monday?
Yeah.
Yeah.
Okay. Good. All right. So, part B of this question now asks us to find what's our final location, right? How far did we travel? Distance traveled during the 4 seconds. So what I'm going to do is, since I made the starting position 0, whatever number I get for the final position will also be the distance traveled. Now, Dominic could go, I think I'll make the starting position 10. That's great. But then he'll have to remember to subtract from final to initial, things like that. But you can't do that. You can pick any number you want for the starting position. 0 is just easy. So in this one, the best equation to use would be this guy, because it's already solved for distance. And in this case, actually positions. So x final, I don't know. X original, I picked to be 0 meters. Velocity to start with was 2 meters per second. Time was 4 seconds. And then I'm going to need to move down to the next line. Plus 1/2. Acceleration was 2 meters per second squared. And time is still 4 seconds. And it gets squared. So 0 meters. The reason I'm showing you the units is they work just like, variables in math class. So when I have 2 meters per second times 4 seconds, the seconds will cancel out and I'll be left with 8 meters. So now I've got meters and meters, and I should have meters because this is going to be a distance. Okay? And then on this last one, I have the 2 and the 2 cancel out. And this is going to be a seconds squared. So the second squareds are going to cancel out, and that'll leave me with meters. How many meters? 4 squared meters. So this would be 16 meters. So now we have like terms that we can add together. Get 24 meters. Kind of okay? They get easier. In a few weeks you'll be doing them without thinking, but right now I know it's still very new. Okay, next question. Yeah, Connor.
Number 3.
On the same one?
Yeah.
Okay. Number 3. Number 3 says, physics student is driving home after class. Car is traveling 14.7 meters per second when it approaches an intersection. Student estimates that he is 20 meters from the entrance to the intersection when the light changes from green to amber and the intersection is 10 meters wide. The light will change from amber to red in 3 seconds. The maximum safe deceleration of the car is 4 meters per second squared, while the maximum acceleration of the car is 2 meters per second squared. Show the physics student, should the physics student decelerate and stop or accelerate and travel through? Should you speed up to get through the light or should you stop? What's the safe thing? Well, if I want to be safe, one way or the other, I need to not be in the intersection when the light turns red. That's bad. Okay? So what I'm going to do is I'm going to solve this problem for both scenarios and see which one is the better choice. Okay, so let's see. If we choose to speed up, or slow down. Let's do the choose to speed up one first. So, what do we know about this problem? Well, I'm here. I'm here someplace, and I'm getting up here to an intersection. The intersection is 10 meters wide, and I am currently how far from it? 20 meters from it. So I'm going, 20 meters from here to here. So to speed up, what do I need to do? X final, X original, V original T, 1/2 AT squared. I'm going to want my X final to be at least 30. So I'm going to say, let's just barely get across. Start at 0. You could also work this one as I need to go 10, and I'm already at 20. That's another way to work that. This is just easier, though. Okay, and what's our velocity? 14.7. And how many seconds do I have? At best, I have 3 seconds, right? We'd like it to be less than that, but we'd also like our tail not to be hanging in just barely in the intersection when the light turns red. And then, of course, our acceleration speeding up is 2, and our time is 3 at best. So this is best case scenario I get through. So let's see what we get here. 30 equals, and these are not actually equal. We're seeing if they're in the game. So 14.7 times 3, calculator. Plus 53.1. So what does that tell me? I can make it. And I cannot just make it, I can make it with plenty of space. Okay? What happens on the other one? Well, same basic setup. But this time the acceleration is -4. Is that right? 4. It's 4 and negative because you are trying to slow down. Your brakes push you back the opposite direction. This would be 3 squared. Okay. So now we have 14.7 times 3 plus 0.5 times -4 times 9 . This one would say you stop in the intersection, which would most definitely be bad.
I love how it says there's a police car there.
Yes. Yes. So in this case, the police would probably expect you to keep going because that is less dangerous to everybody.
Behind me.
Yep. I know that we had a teacher here who shall remain unnamed to protect the guilty in this case that got pulled over on the interstate one time passing a semi-truck she's going about 85 or so, because you got to get around. And cops pulled her over. Was not me, by the way. And I thought this was hysterical because this person does not teach physics, but said, "Officer, I'm sorry, I just coasted. I was coasting. I sped up to get around him, and then I kept going because I didn't want to lose all that momentum. I mean, I already built off all the momentum. I might as well use it while I'm going forward." It's actually a physics argument. And the cop thought it was good enough and let her go. So maybe if you speak physics, you can get out of speeding tickets. It's never worked for me, personally, just so you know. But I haven't gotten one in many years now because I'm better at that kind of thing. I don't speed less. I just speed smarter.
Yeah.
Okay, so how's that? Is that okay for you? Okay. Next question. Number 4. All right. Well, I already gave you the answers, so it's not like you don't have the answers, right? You just don't know how to get there. Did I? Oh, I didn't on these. Okay.
I think you did. I didn't realize that was.
Yeah, at the back. The very last page has all the answers on them. I know, right? That's the problem, right? It's not always about having the answer. If you don't know how the answer came about, it's kind of useless information. Okay, number 4. This is when I start drawing pictures for real, because I have to understand what's going on in the problem. I have to be able to think physics, but a lot of times thinking physics means you have to see what's happening. So a car traveling at a constant speed of 30 meters per second passes a highway patrol police officer, which is at rest. Police officer accelerates at a constant rate of 3 meters per second squared and maintains this rate of acceleration until he pulls next to the speeding car. Assume that the police car starts to move at the moment the speeder passes his car. Determine the time required for the police officer to catch the speeder and distance traveled during the chase. So, what do I have going on here? So we've got, here's our highway, and let's give ourselves a little cop car. Here's my little cop car. Velocity is 0 to start with. You can't see that. There we go. And we have speeder guy. Make his car look like that. Which is not a good car drawing, but you'll deal with it because I've already told you I can't draw. So, we've got our 2 cars. This car is going 30 meters per second. Am I remember that right? Okay. So, they both start moving when? So, at time equals 0, they both start moving. Actually, one of them is continuing to move. They're both at the same location. So, what does it mean for the cop car to catch up to the speeder? What does that really mean? We need to be at the same place at the same time. I need to be at the same place at the same time. Which means over here somewhere, I should see cop car. I should see cop car beside speeder car. So this is what I need. Same place, same time. So, same place, same time. Same place, same time means this. Distance by speeder needs to equal distance by cop. You guys buy that?
Sure.
Because if I'm going to get there at the same time, here's the problem that I have. I don't know the time, and I don't know the distance. And I can't know the final velocity of the cop because without the time and the distance, I don't have any way of getting there. So I'm in a situation where none of my equations sort of capture all the information about the police officer. But I can do this. I can do this by figuring out if I know how far the speeder went in some amount of time, it was the same time for the cop. So even though I don't know the time, it's the same time for both of them. And then maybe it'll cancel out. So that's where we're going with this. So what is the distance by the speeder? Well, it would be x original plus v original t. So this is x final for the speeder plus 1/2 a t squared equals x original v original t, 1/2 a t squared equals final position for the cop. So I take those two distance equations and set them equal to each other. And I know this looks worse. I'll give you a second to see if you can fill that in. Is that what you Okay, so, good, just a second. Let me put this back up there. What do the letters mean? So my initial position, I typically get to pick that. So I'm going to make it 0, and it'll be 0 for both. But let's say Chase likes the number 13, just for fun. And if he puts 13 here and 13 here, it still doesn't matter because this is the same number in both cases. You follow? Okay, so what's going on with our speeder? Our speeder is going at a constant speed of 30 meters per second. That's around 90 miles an hour, just so you know. So we go, okay, he's going 90 meters per second. Oh, 30, yeah, sorry. Losing my mind. I told you guys, I'm having a day. And then the time, we do not know. And the acceleration is going to be, oh, hey, the acceleration for the speeder was 0 because they didn't speed up. They stayed at a constant speed. Yay, that makes the left side a lot easier to deal with.
And it's just the same thing on the other side.
And on the other side, though, I've got the cop. How fast was the cop going to start with?
0.
Yay, I like zeros. This one goes. But this one doesn't. He's accelerating at what? Yep. 3 meters per second.
So since
Squared.
it has the 1/2 acceleration times time squared on both sides, you just cancel it out?
No. Oh, if it's the same value, yes. But in this case, they're not the same value. The 0 here is because the speeder does not change speeds. They do not accelerate. But here, they are.
So when it accelerates, it's squared.
What squared?
What the acceleration? Like 3 meters a second.
Does the A get squared, or are you talking about the units?
Yeah.
No. The A does not get squared. The time gets squared. Yep. So this side is now 30t meters per second. This side is now 3/2 t squared meters per second squared. And now I have to do algebra. Oh no. Here's my algebra. I'm going to subtract 30 from each side. I'm going to drop the units for just a minute. So I'm going to have 0 equals 3/2 t squared minus 30t plus 0. Hey, I could use the quadratic formula. Or hey, I could factor. I factor. I happy factor. Let's see, 65 by 3 would be 20. 0. I factor. If you don't know how to factor, calculus is going to be brutal. Yeah, Nathan? Yeah, they just went, yeah, you don't need to factor. Nobody really uses that. We use it in physics all the time. Not you guys in your physics use it all the time. You use it all the time in pre-calc. You use it all the time in calculus. It's one of your most important math skills. Yes.
Okay, so when you factored out 3/2 t, how'd you go from 3/2 t times?
I did, because factoring is division, right? So I divided 30 by 3/2.
Well, no, I know how you did that, but how did you go from 3
Oh.
halves t times t minus 20?
Multiplicative property of 0.
Oh,
You
so
ever
can
heard
multiply
that?
by anything in
If
order
you
to get-
multiply two things together and you end up with a 0, somebody had to be 0.
Okay.
So either time was 0 or time was 20.
Mhm.
But we knew that because at time 0 they were together. They started together. Which means the answer for our question would be time equals 20 seconds,
20, I'm sorry.
because that's when they get back together. So they started together at time equals 0. They ended together at time equals 20.
And that's only part A.
That was part A, yeah.
And is this what, so what we said up there is a system of equations?
Love you guys. It's going to be all right. Huh?
Is it just a system of equations, pretty much?
Yes.
Okay.
Without showing it as two separate equations and, yeah.
Okay.
Yes, this was a system of equations is what he just asked.
Yeah.
Yeah, it was. You know, like x plus y equals 11 and 2x minus 3y equals 6. And you solve for one of them and substitute in the other one. Yeah, that's what we did. Your math skills at the end of this class will be a lot better. Because, right, it's what we do. But it also should help you understand why you do the math. Because math, and I have a master's degree in it and I love it. And at some point I'll get my PhD in math. Not this year. Not if this continues. But at some point I'll get my PhD and it'll be in math. And I love it. But it's a very abstract art. It requires a language translation. It is translation to a new language. And physics is too, to a certain extent. But it's applied mathematics. Physics applied mathematics. So hopefully now you'll see some places where we use all that crap instead of it just being this rule that you memorize like the quadratic formula that has a song, evidently. So, so now part B. What does part B ask us?
Distance traveled during the chase.
Distance traveled during the chase. So pick one side or the other and fill in time equals 20. We can do the speeder distance or cop distance. They'll be the same number. So which one do you want to use? We'll do cop. Okay, cop. Cop distance would be... No, we got the acceleration for the cop. They gave us that. So we're doing this side. So I'm just going to take all those things I put in. 0. 0 times 20. 1/2, 3 times 20 squared. By the way, if a cop took 20 seconds to catch the speeder, that's way too long. Yeah, they have endangered the populace if you took that long. So this would be 400 seconds squared. Just to show you the units actually do work out to be a distance. So part B this long, part A this long. And Nathan, so far on the AP test, they haven't expected you to do calculus with a graph. Like you have to figure out the equation of the graph and then do the calculus to find the area, or then do the slope. They'll either give you the function and the graph, and you'll integrate the function, or they'll just give you the graph and you'll be doing estimation from algebra. Or geometry if they're doing triangles and rectangles. So the cop went 600 meters. That'd be 6 football fields. That might be reasonable to catch a guy that was going that fast.
You said 90?
Yep, it's around 90.
It is 112 miles per hour.
Oh, 112. Underestimated it then. 112 miles an hour. That makes it more reasonable for it to take him that long to catch up from a dead stop.
Depends on what car.
Pretty sure his car will accelerate better than 3, though.
Depends on the cop car, though.
Yep, it does. Okay. Now we've learned another tool to go in our bag of tricks. So, what's left? Oh, number 2.
Yeah.
Nobody wants number 2?
I want number 2. And number 5. It's still the same. 7.
There's going to be more of these practice problems, just so you know, because I don't really expect you to pick it up in one day. Or 3 weeks, right, Nathan?
You said this is due today?
Not him. His class. I felt like we stayed in this section. And I know we stayed too long, but it was one of those years.
Did you say this is due today? And those 2
Both
papers?
years, yeah.
And those 2 papers, they're both due today?
Start over?
Is this due today?
No, Friday.
What about the other
Everything's
papers?
dead Friday.
The 2 papers?
Yeah,
Those are
so that
due.
you have time to ask questions.
Thank you.
Yep.
So all late work has to be turned in by Friday.
Yeah, well, he asked about these assignments. They're due Friday. But yes, please try to get your late work in like now, because I really am dying. Like yesterday I worked from 5:30 in the morning till 8:30 at night, and I only took the break to give the ACT and an hour break at my house, 30 minutes for video gaming and 30 minutes for dinner. And then I was tired of grading. But all the papers AP1 had turned in and were graded as of last night. Now, stuff that comes in today, I'm going to try to stay on top of it from here. But I'm working on the standard physics right now.
Try is the key.
Yeah, the try. And he'll tell you, on a normal year, you get your papers back the next day from me. There's not even a question about it. You always do.
Yeah, it's all on.
And now I have to find you, I have to find which worksheet you did, I have to open it or download it or Zoom it or, yeah, something. So, okay, so number 2, since he's the lonely left friend out here, and hopefully this will give, the reason these are called guided practice, anybody have a guess as to why these are called guided practice? Because they don't guide you how to solve the problem. So what are they guiding? They're guiding you in the bag of tricks to learn how to solve these. They are showing you the most common things you have to do to solve kinematic equations. That's what they're guiding. Okay. All right, so number 2. Car is traveling at the posted speed limit of 6.7 meters per second in a school zone. The car is passing a school bus when a child darts out from in front of the bus. The car is 10 meters from the child when the driver applies the brakes. The car decelerates. That's an English word. What it means is negative acceleration in this case. 4 meters per second squared until coming to a halt. Calculate the distance the car travels while decelerating. Which equation would be the best one to use here? I'm going to put this over here. So we know x original, I can call it 0. X final is going to be 10 meters or less, right? Why is it 10 meters or less? We do not want to hit the child. The child is 10 meters away. We don't want to hit the child. Well, you know, the child applies the same force on my car that the car applies on the kid. So it ain't the forces that are the problem here. Velocity, original, of the car. Do we know that? The car was traveling at 6.7 meters per second. And we want the final speed to be 0, so we stop and don't hit the kid. Remember the big picture here. Don't hit the kid. Well, in my life, because I've had a friend whose dad drove over their 2-year-old. He backed out of the driveway and drove over the child. So I know 2 people that are friends of mine that have happened to. So it's not cool. So we joke, you know, it's okay. I'm fine. Okay? And I know we all joke about stuff like that because I do too. But it would be traumatizing. I can almost promise that.
Oh, yeah. For the driver,
Yeah.
Forever.
I'm guessing the child didn't.
And no, neither case actually. So she was playing in the yard, and Dad didn't see her as one of those. This is why SUVs now have a rear view camera, is because this happens a lot more than you realize. But couldn't see behind them, and they saw Daddy leaving and ran out behind. You know, things happen. So really unfortunate. But as a Christian, that doesn't. It bothers me, but it doesn't. Well, let's see. There's only one of them that doesn't have time in it, right? There's one equation that does not have time. So that would be the best one to use here. And what am I assuming? Right here, I'm assuming we get stopped, right? I'm assuming we get stopped. I will get stopped eventually. The trick is, do I do it in the right distance? So I'm going to use the V final squared equals V original squared plus 2A final position minus initial position. So 0 squared equals 6.7 squared plus 2, negative 4, and 10. Zero squared is 0. I don't know what 67 is squared. I only get up to about 40s on those. 44.89. This would be negative 8 times 10 is negative 80. That can't be right. Oh yeah, it can't be right.
Would it be positive?
No, but it'd be negative because we're slowing down. So what does this tell me? These two numbers obviously not equal. What does that tell me? There wasn't enough time for me to stop. How far did I go? How far did I go? 35.11 meters. There's no way I could stop. It was too close. I was going too fast and it was too close.
So you went 25 meters after hitting the kid?
Yes.
How fast? What is this physics? How fast was it going?
Well, Nathan, what were the one we were talking? Oh yeah, the bullet problem the other day. It was shooting a bullet and